Okay, I just wanted to make a quick video response that this might be some aberration of the function generator that's causing this effect. I don't believe it is. Exactly what's important for this effect, though, I don't currently know yet. So instead of running the function generator directly into the L1, I'll be using the small gate driver IC. You might recognize that from the resonance induction coupling kit. I will still be keeping this arrangement, this parallel series arrangement. This is supposed to increase the magnetic field strength at resonance. I'll post a link in the description that provides a lot of the math around that. But let's see what happens now. So I have my power supply set up at 12 volts going into my gate driver IC, and we're running at a little bit lower frequency than we were before, but I've been kind of playing around with the position of the L1 within the L2. We are running in pulse mode, and we have a duty cycle of 25%. So let me start it up and let's see what we get. And I think there you still see the exact same effect we were seeing before. I can short it out. The trumpet wave profile and that kind of snapback after the acceleration phase at the very end and resetting into final voltage. I can reduce the frequency a little bit and we get a quicker ramp to peak, but a lower final voltage. And I suppose if I increase the frequency to 1.59, we'll get a very slow ramp up. Maybe that's too slow. Go down. There it goes. Really slow ramp up, but higher final voltage. And again, there we're at 12 volts. Just for fun, let's increase this to, I don't know, 20. And let's see what happens. Now what's interesting there is, for some reason, when the voltage is higher, I also get the quicker ramp up. And I guess in theory then I could also increase my frequency. And I get the slower ramp up with a higher final voltage. Now, one last thing I want to comment on is, I know it kind of looks like my scope is really weird. You see a frequency of 2.7 hertz. This is purely an aberration of the scope. Because I'm at this very large time scale, the sample rate is lower. If I were just to do something very simple, like increase this by 1 kilohertz, you'll see you get this fogginess on the scope. So it just seems to be, so when I'm at this multiple of 10 kilohertz, you get what looks more like a sine wave, but it's not a true sine wave. If I zoom all the way in, you'll be able to see the actual sine wave. And there you would expect with the gate driver IC, since we're pulsing, you would expect to see one peak higher than the other. And again, if I short it out, you see a sine wave the entire way pretty much, but you see that acceleration towards the end. And I'll try one more time. There we go. Thanks for watching. Hopefully that relieves some concerns, but there's still a lot more to learn for sure. Thanks.